NFPA 70E, the standard for electrical safety in the workplace, serves as the primary document for establishing electrical safety requirements in workplaces throughout the United States. The latest edition, the 2023 edition, was released in June 2022. Arc flash protection is about measures implemented to reduce the dangers associated with arc flash events, which can lead to severe burns, injuries, and damage to equipment. While NFPA standards aren't directly enforced by OSHA or any other federal agency, many state and local jurisdictions incorporate NFPA 70E into their electrical safety regulations. This means that employers in those areas must comply with the standard. The 2023 edition of NFPA 70E introduces important changes related to arc flash protection. These changes include updated arc flash hazard analysis, or NFPA, requirements, new methods for calculating arc flash boundary distances, and revised tables for personal protective equipment, or PPE, selection. The enforcement of the 2023 edition of NFPA 70E depends on the specific jurisdiction. Some states and local authorities might adopt the new edition immediately, while others may take more time to update their regulations. Employers should check with their local authorities to determine when the new requirements will be enforced in their area. The changes in the 2023 edition of NFPA 70E can have several implications for employees. These include the need for additional training and analysis for employees working on electrical systems, an increased need for PPE to protect workers from arc flash hazards, and potential effects on the design and installation of electrical equipment. To ensure compliance with NFPA 70E, employers should take several actions. Firstly, familiarize themselves with the changes introduced in the 2023 edition. Secondly, conduct a thorough NFPA to identify potential arc flash hazards in the workplace. Thirdly, provide appropriate PPE and training to employees who work with or near electrical equipment. Fourthly, establish a comprehensive electrical safety program that outlines procedures and protocols for working safely with electricity. Fifthly, monitor updates from OSHA and local authorities regarding the enforcement of NFPA 70E and other relevant safety regulations. Arc flash hazard analysis, or NFPA, is a critical process for identifying and assessing potential arc flash hazards in the workplace. The purpose of an NFPA is to determine the incident energy levels and arc flash boundary distances for specific electrical equipment and tasks. This information is then used to select appropriate PPE and establish safe work practices. Arc flash boundary is the distance from energized electrical equipment within which a person could receive a second-degree burn if an arc flash occurred. The arc flash boundary depends on factors such as the voltage level, available fault current, and clearing time of the overcurrent protection device. Incident energy is the amount of thermal energy generated during an arc flash event, typically measured in calories per square centimeter. Incident energy levels are used to select appropriate PPE that can protect workers from burn injuries. Personal protective equipment, or PPE, is essential for protecting workers from arc flash hazards. PPE includes items such as arc-rated clothing, face shields, helmets, gloves, and footwear. The selection of PPE should be based on the incident energy levels determined during the NFPA. The Electrical Safety Program is a comprehensive set of policies, procedures, and practices designed to protect workers from electrical hazards. An effective electrical safety program should include elements such as hazard identification, risk assessment, safe work practices, training, and PPE requirements. Safe work practices are specific procedures and techniques that workers must follow when working with or near electrical equipment. Safe work practices should be designed to minimize the risk of electrical shock, arc flash, and other electrical hazards. Training is essential for ensuring that workers are aware of electrical hazards and know how to work safely. Training should cover topics such as arc flash awareness, hazard identification, safe work practices, and PPE requirements. Compliance with NFPA 70E is essential for protecting workers from electrical hazards and avoiding potential fines and penalties. Employers should take proactive steps to familiarize themselves with the standard, conduct a thorough NFPA, provide appropriate PPE and training, and establish a comprehensive electrical safety program. Several factors can influence the severity of an arc flash event. These include voltage levels, available fault current, working distance, and enclosure size. Higher voltage levels generally result in higher incident energy levels and larger arc flash boundaries. Available fault current refers to the amount of current that can flow through an electrical circuit during a fault condition. Higher fault currents result in higher incident energy levels and more severe arc flash events. Working distance is the distance between a worker's body and the potential arc flash source. Closer working distances result in higher incident energy levels. Enclosure size can affect the severity of an arc flash event. Smaller enclosures can concentrate the energy of an arc flash, leading to higher incident energy levels. In addition to PPE, other safety measures can be implemented to reduce the risk of arc flash hazards. These include de-energizing equipment before working on it, using remote racking devices, and implementing energy-reducing maintenance switches. De-energizing equipment before working on it is the most effective way to prevent arc flash incidents. When possible, electrical equipment should be de-energized and locked out before any work is performed. Remote racking devices allow workers to operate circuit breakers and other electrical equipment from a safe distance. This reduces the risk of exposure to arc flash hazards. Energy-reducing maintenance switches can be installed on electrical equipment to reduce the available fault current during maintenance activities. This can significantly reduce the incident energy levels and arc flash boundaries. NFPA 70E is updated every 3 years to reflect changes in technology, industry best practices, and regulatory requirements. It is important for employers to stay up to date with the latest edition of the standard to ensure that their electrical safety program is effective and compliant. The 2023 edition of NFPA 70E includes several significant changes that employers should be aware of. One important change is the updated requirements for arc flash hazard analysis. The new edition provides more detailed guidance on how to conduct an NFPA and determine the appropriate level of PPE. Another important change is the revised tables for PPE selection. The new tables provide more specific guidance on selecting PPE based on the incident energy levels determined during the NFPA. The 2023 edition of NFPA 70E also includes new requirements for electrical safety training. The new requirements emphasize the importance of hands-on training and the need for workers to demonstrate competency in performing electrical tasks safely. Employers should review their existing electrical safety training programs to ensure that they meet the new requirements. In addition to the changes in NFPA 70E, employers should also be aware of other relevant safety regulations and standards. These may include OSHA regulations, state and local electrical codes, and industry consensus standards. OSHA's electrical safety regulations are found in Title 29 of the Code of Federal Regulations, Part 1910.301 through 1910.399. These regulations cover a wide range of electrical safety topics, including wiring methods, equipment installation, and safe work practices. State and local electrical codes may also have specific requirements related to electrical safety. Employers should consult with their local authorities to determine which codes and regulations apply to their workplace. Industry consensus standards, such as those published by the Institute of Electrical and Electronics Engineers, or IEE, can provide additional guidance on electrical safety best practices. Staying up to date with the latest safety regulations and standards is essential for ensuring that your electrical safety program is effective and compliant. Employers should regularly review their safety programs and make any necessary updates to reflect changes in the regulations, standards, and technology. Arc flash studies are a critical component of an effective electrical safety program. An arc flash study is a detailed analysis of an electrical system to determine the potential arc flash hazards. The results of an arc flash study are used to develop safe work practices, select appropriate PPE, and determine the arc flash boundary. An arc flash study typically involves collecting data about the electrical system, such as voltage levels, available fault current, and clearing times of overcurrent protection devices. This data is then used to calculate the incident energy levels and arc flash boundaries at various locations throughout the system. The results of the arc flash study are typically presented in a report that includes one-line diagrams, incident energy calculations, and PPE recommendations. The report should also include recommendations for improving the electrical safety of the system, such as reducing the available fault current or improving the clearing times of overcurrent protection devices. Arc flash studies should be performed by qualified electrical engineers who have experience in arc flash hazard analysis. The study should be updated whenever there are significant changes to the electrical system, such as the addition of new equipment or changes to the overcurrent protection devices. Electrical safety audits are another important component of an effective electrical safety program. An electrical safety audit is a systematic review of an electrical system to identify potential hazards and ensure compliance with safety regulations and standards. An electrical safety audit typically involves a physical inspection of the electrical system, a review of safety procedures and training records, and interviews with employees. The audit should be conducted by qualified electrical safety professionals who have experience in identifying and assessing electrical hazards. The results of the audit should be documented in a report that includes findings, recommendations, and corrective actions. The report should be reviewed by management and used to develop a plan for addressing any identified hazards. Electrical safety audits should be performed on a regular basis to ensure that the electrical system is maintained in a safe condition and that employees are following safe work practices. The frequency of audits should be based on the complexity of the electrical system and the potential hazards involved. Lockout-tagout procedures are essential for preventing electrical accidents during maintenance and repair activities. Lockout-tagout is a safety procedure that involves energizing electrical equipment and applying locks and tags to prevent the equipment from being accidentally energized. The purpose of lockout-tagout is to protect workers from electrical shock and other hazards while they are working on electrical equipment. Lockout-tagout procedures should be followed whenever electrical equipment is being de-energized for maintenance or repair. The procedures should include steps for identifying the equipment to be de-energized, disconnecting the equipment from the power source, applying locks and tags to the disconnecting means, and verifying that the equipment is de-energized. Only authorized employees who have been properly trained should perform lockout-tagout procedures. The employee should be familiar with the specific lockout-tagout procedures for the equipment they are working on. The locks and tags used for lockout-tagout should be standardized and clearly labeled to indicate that the equipment is de-energized. The lock should be unique to each employee and should not be able to be opened by anyone else. Electrical safety training is essential for ensuring that workers are aware of electrical hazards and know how to work safely. Electrical safety training should cover a wide range of topics, including arc flash awareness, hazard identification, safe work practices, PPE requirements, and lockout-tagout procedures. The training should be tailored to the specific hazards and tasks that workers are exposed to. The electrical safety training should be provided to all employees who work with or near electrical equipment, including electricians, maintenance personnel, and operators. The training should be conducted by qualified instructors who have experience in electrical safety. The training should be updated on a regular basis to reflect changes in safety regulations, standards, and technology. In addition to formal training, employers should also provide ongoing safety reminders and toolbox talks to reinforce safe work practices. These reminders can help to keep safety top of mind and prevent accidents. Proper grounding is essential for preventing electrical shock and equipment damage. Grounding provides a low resistance path for fault current to flow back to the source, which helps to trip over current protection devices and prevent electrical shock. All electrical equipment should be properly grounded in accordance with applicable electrical codes and standards. The grounding system should be inspected on a regular basis to ensure that it is in good condition and functioning properly. Grounding electrodes, such as ground rods and ground plates, should be installed in accordance with electrical codes and standards. The grounding electrodes should be connected to the equipment grounding conductor system. Equipment grounding conductors should be sized according to the size of the circuit conductors and should be installed in accordance with electrical codes and standards. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect people from electrical shock. GFCIs monitor the current flowing in a circuit and trip the circuit if they detect a ground fault. A ground fault is a condition where current is flowing through an unintended path to ground, such as through a person's body. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas, where there is a high risk of electrical shock. GFCIs should be tested on a regular basis to ensure that they are functioning properly. Surge protection devices, or SPDs, are devices that are designed to protect electrical equipment from voltage surges. Voltage surges are sudden increases in voltage that can damage or destroy electrical equipment. SPD work by diverting the surge current to ground, thereby protecting the equipment from damage. SPD should be installed on all critical electrical equipment, such as computers, servers, and medical equipment. SPD should be selected based on the voltage and current levels of the electrical system. SPD should be inspected on a regular basis to ensure that they are functioning properly. Proper wiring methods are essential for ensuring the safety and reliability of electrical systems. Wiring methods should be in accordance with applicable electrical codes and standards. Conductors should be properly sized for the load they are carrying. Conductors should be protected from physical damage. Connections should be made using approved connectors and methods. Wiring should be installed in a neat and workmanlike manner. Overcurrent protection devices, such as fuses and circuit breakers, are designed to protect electrical circuits from overloads and short circuits. Overloads occur when a circuit is carrying more current than it is designed to handle. Short circuits occur when there is an unintended path for current to flow, such as when two conductors come into contact with each other. Overcurrent protection devices should be sized properly for the circuit they are protecting. Overcurrent protection devices should be installed in accordance with electrical codes and standards. Overcurrent protection devices should be tested on a regular basis to ensure that they are functioning properly. Electrical equipment should be inspected on a regular basis to ensure that it is in good condition and functioning properly. Inspection should be performed by qualified electrical personnel. Inspection should include a visual examination of the equipment, as well as testing of electrical components. Any defects or problems should be corrected promptly. Electrical equipment should be maintained in accordance with manufacturer's recommendations. Preventive maintenance, such as cleaning and lubricating equipment, can help to prevent equipment failures and extend the life of the equipment. Electrical safety is a critical concern for all workplaces. By following the recommendations outlined in this overview, employers can create a safe and healthy work environment for their employees. Remember to consult with qualified electrical professionals and stay up to date with the latest safety regulations and standards.